Alrighty, hopefully the audio is working. I was having some issues on a live stream the other day, and the audio was cutting in and out. Hopefully this works this time. We'll get started. It doesn't look like there's many people want to watch, but I will do some questions along the way here, and hopefully some people join in. So this section that we were working on was 3.3 on the worksheets. It's a cumulative review of everything to date. That includes the perimeter area, bed mass, Pythagorean theorem, composite figures, maximizing the area of rectangles, and volume topics that we've been looking at. So I have a few questions for us to look at, if unless someone comes along with a request. Again, have a request, just send me a message through Edsby or email. And again, if you're not going to be able to make a live stream but you want to ask questions, send them before the videos. If you send questions, I can take them up. Even if it's on something previous, I can do a little lesson video or topic on that during the live stream. So, getting started here, we're looking at the cumulative review out of the textbook. And so the first couple questions here, we're looking at the perimeter of each shape. We have a square, a triangle, and a quadrilateral. It's not actually a square or a trapezoid or anything. It's kind of misshapen. But in all three cases, what we're doing is we're finding the perimeter, or the distance around the object. Again, perimeter is just the sum of all the sides. So in the case of the rectangle, we're just starting in one corner. If we were to walk around that all the way around, that's what we're looking at. So these little tickies again mean that sides are the same. So in the case of number 1 there, we're just adding up all the sides. 1 plus, or 5.8 plus 5.8 plus 5.8 plus 5.8. And that'll get us the result. So just to quickly do that one, we'll switch over here. We have number 1. Oh, my pen doesn't want to work. 5.8 plus 5.8 plus 5.8 plus 5.8. That's going to be the perimeter of that shape. We just add all those up, or multiply 5.8 by 4 as a shortcut, and the perimeter equals 23.2. And thus the perimeter of this shape is 23.2 centimeters. So pretty straightforward with the perimeter. Not much going on there. But if you take a look at the next ones, okay, so you do the same thing with the next two as well. You just add up the sides on those. In the case of B, it's 7.4 plus 5.2 plus 5.2. These two sides of the isosceles triangle here are 5.2. And then the last one, we're just adding up the 4 numbers to get the total distance around. Working with the next set of questions, we're working on some area, and we want to estimate and then calculate the area. So taking a look at part A, we have 9.6 centimeters. We want to get the area. So the area formula is pi r squared. So pi is 3.14, and r is the radius, or half the distance across the circle. Well, half the distance across the circle is well, 9.6 is almost 10, so it's about 5. And 3.14 is about 3. So I'm going to say a good estimate would be 15 or 16 centimeters squared. Might be a good estimate. Or sorry, no, that would be a bad estimate. We forgot to square it. 5 squared, the radius squared, so 5 squared is 25. 75. 75, maybe 80 would be a good estimate on the area of this circle. So I'm going to estimate 80. And then if we actually calculate that, we have, so this is number 2a, area equals pi r squared, so 3.14 times half of 9.6 is going to be 4.8. We're going to square 4.8. And when we do that, we get 72.3 centimeters squared. So I was a little high on my estimate. It's a little bit lower than what I was thinking, but 72.3, I said about 75 to 80. Pretty close, good estimate, I think. So again, in the next one, you do the same type of thing. You have 2.2 meters, and so estimate, make an estimate there. Radius is about 1, so the 1 squared is 1. It's going to be about a little over 3.14. Would be maybe 3.5 might be the area of that next one, and then you can actually calculate it by plugging that into the formula. And number 3, you're just looking at using bed mass, so brackets and then exponents, division or multiplication, whichever order they appear in, so you do whatever comes first, and addition and subtraction in the order that they appear. So that's a bed mass. So in the first one, you do 5 squared for 25, and then you do 3 times 4 for 12, so you'd have 25 minus 12, or 13 as your answer. When you get to the part C, where you have that square root sign, that radical, what you got to do is everything inside the radical first, and then take the root of it. So just like part A, you do your 5 squared for 25, do your 4 times 6, which is going to give you 24, and 25 minus 24 is going to give you 1, and the square root of 1 is simply 1. So that would be a description of doing those. In part 4, just a little work with using a formula. So you take 6 or s equals 6l squared, and we find the surface area of a cube with each of these varying lengths. So we just substitute in 2, 30, and 1.5 for the L. So you'd have 6 times 2 squared, 6 times 30 squared, and 6 times 1.5 squared. And so we'll do a quick little example with that one there. So that's number 4. So S equals 6 L squared, and what I'm going to do is replace that L with the first value, which was 2, 6, 2 squared. Notice I put the 2 in the parentheses. Whenever we substitute in variables, we should put them in parentheses in case they are negatives, and that parenthesis makes a difference, especially in our calculators and things like that. And so we can calculate that now. 2 squared is 4, 6 times 4 is 24 centimeters squared, and that would be the surface area of that cube. I flip back over to the textbook here, and we'll look at the next one. solve for the missing length in each triangle. So this is Pythagorean theorem. That was one of the big things that we worked with. We did a lot of worksheets on that, lots of triangles. Two different situations. Sometimes you're finding the hypotenuse. Sometimes you're finding one of those shorter sides of the triangle. A, we have a missing hypotenuse. B, we have a missing short side. And C, we have a missing short side. So I'm going to pick one of the tougher ones, and I'm going to do B. So I'll switch back over here. And so this is 5B. And again, we had a triangle, just a quick little sketch of it. So we had a triangle upright like that, right angle, 3.9, 8.0. Those units were meters. And so this is my missing side. I'm going to call it A. So there's that triangle. And now the Pythagorean theorem is a squared plus b squared equals c squared. And the c squared is our hypotenuse. The hypotenuse, again, is pointed at by that right angle right here. So we have the 0.8 or 8.0, sorry, squared as our c value. We're missing our a value, so we leave that. And our b value was 3.9, and we square that. So there's our formula. This is going to require some of that subtraction to make it work. So a squared plus, and I'll just square out my numbers. 3.9 should give me about 15.8, 15.2. 15.2, and 8 squared should give me 64.0. And then, because we're adding 15.2 here, we got to get rid of it. How do we get rid of it? We subtract it, the opposite of adding. We do that from both sides. So plus 15.2 minus 15.2 equals 64.0 minus 15.2. We subtract that 15.2 from both sides. On the first side, you're just going to get a squared left over. And then 64 minus 15.2 is going to give you 48.8. And now the last step is that we got to take the square root of this. So we got to take the square root of a squared. That's the opposite. And how we get rid of it, we take the square root then of 48.8. Whatever you do to one side of the equation, you do to the other side. So we're just left with a on that side. And the square root of 48.8 is approximately 6.98, which would round up 7.0. So our missing side here is 7 meters long. In the case of, and I'll switch back here to worksheet. In the case of A, you have the hypotenuse being the missing side. So you would have your a and b values. The only difference here is you would be able to add your a and b's instead of having to subtract. Just to talk about number 6, the Kim family are redecorating their kitchen and dining room. What are we doing here? Well, we're looking for the perimeter of the room. We want the whole perimeter, so we include the doors. Okay, those doors are marked off by the little, looks like a door opening into the room. Those are the 2 doors. So the 0.9 meters. There's 2 of them there, one at the top, one at the bottom. We use those as well. We're calculating, but we're not going to add them in as part of our perimeter, because this whole wall, and I'll redraw this, but this long wall at the top is marked off as 6.8. So it's not 6.8 and 0.9 meters. It's a full 6.8 meters all the way across. All right, so if I switch back over here, so the room's approximate like this. So this whole side 6.8, and the short side here is 2.1, 4.8, and 3.0. And I'm ignoring the doors right now because we don't need them for the perimeter. But we're missing this little bit right here. It's easy to find though. Recall that if this whole side from here to here is 6.8, then this whole piece right here would be 6.8. This is 3. How much is left? 3.8. And that's just 6.8 minus 3. So now we can add all those up, get the perimeter of the room. And our perimeter in this case would be 6.8 plus 4.8 plus 3.8 plus 3. Oh, I missed one. We missed this side right here too. This side was missing. But again, same process here. This whole side's the same as this whole side. So we have 2.7. Add that in as well. And looks like 23.2. So we got 23.2 meters is our entire perimeter around that room. The next question says there are 2 doors. Those are the 9.9 meter wide pieces. What's the total length of baseboard to be painted? So that's that trim that goes around the between the wall and the floor to hide any gaps between them. What would we do to solve that? Well, we would just take our 23.2 and subtract the 0.9 meters each time because we don't need baseboard going across the door. And then the next part is what area of carpet do the Kims need to buy? Well, to find the area, we can break this shape up into 2. So if I flip back over here, oh, I never went back to the questions for you guys. Yeah, so there's that 2 doors, 9 meters wide. And then the last question, what area of carpet do the Kims need to buy? So in that case, we have 2 rectangles here. And we can cut it here, or we can cut it here. I'm going to cut it this way. So I have an area of 3.8 times 4.8 for the area of the first rectangle, and then 3 times 2.1 for the second rectangle. So I just multiply those out, add the 2, and I will get an area here of 24.54 meters squared. And so that's how much carpet the Kims would have to order. Going over to the next questions here on the next page. We have the organizers decide to create a temporary parking lot in a field. There are enough stakes and rope for 270 meters of fencing, and entrance and exit are required, each 5 meters wide. Edge of the field is to be used for one side of the parking lot. Design a plan for a parking lot creating as much area as possible for the cars. Well, if you recall, the area that maximizes a rectangle is a square. So we want to make a square. So in number 7 here, we are making a square, but we have an edge of the field to start with, and then we got to make a square around it. So all 3 sides, these 3 sides, will be the same, but there's one little extra piece that we need, and that's an entrance and an exit. So instead of having, we can have an entrance, say here, and an exit here. What that does is it gives us an extra 10 meters of space to go around. So we actually have, instead of 270 meters of fencing alone, we have the 270 meters of fencing plus our 2 5-meter entrances. So we have 280 meters in total to go all the way around these 3 sides. And then we divide that by 3. We just divide that by the 3 sides. And each side should be 93.3 meters, approximately 93 and a third. The other option, and it won't give you quite as much space, but a good idea might have been to divide the 270 by 3, got 90 in each case, and then just added the entrance and exit to either this one side or to these sides, making them slightly longer. But I would just maximize the total area and get my 93.3 meters by dividing. That would be my plan. So each side here is 93.3 meters. In number, I didn't switch that back over. Sorry about that. There's my lot. There's my field. There's my 3 sides. And the entrance, exit. There's my 93 meters. So 280 total. So that's that calculation. Again, my apologies for not switching that over while I was busy teaching you guys. Probably would have helped to see that as I was going. But again, 3 sides of the fencing with the entrances, making a total of 280 meters divided by 3. Now I'll transition back to the this. Last 2, you're just working on some volume type questions. Cylindrical tank has a diameter of 2.60 meters and a height of 1.65 meters. Sketch the tank. So you're just going to make a cylinder similar to this guy down here in number 11, beside number 11. Determine the volume of the tank. We just use our volume formula, which is pi r squared h. So we'll divide that 2.6 by 2 and do pi times 1.3 squared times 1.65. And then we want to convert that to liters. Recall that 1 cubic meter is equal to 1,000 liters. So we just multiply volume by 1,000. And then in number 9, as a description of that, high bounce sports balls are made from a special elastic compound. The compound is poured into molds in liquid form. If each ball is to be 3.2 centimeters in diameter, how many balls can be made from 12 liters of the compound? Well, we're going to find the volume of the balls. So 3.2 diameter, again, volume of a sphere is 4 divided by 3 times pi r cubed. So we would need the radius. 1.6 would be half of 3.2 diameter. And so we'd have 4 divided by 3 times 3.14 times 1.6 cubed. That would give you the volume, which you could then divide 12,000 by to get the actual result. Why 12,000? Because we have 12 liters of material, and each liter is 1,000 cubic centimeters, thus 12,000 cubic centimeters. So a little descriptor of how to do some of these questions. I think that hit all of them. Hopefully that will help some of you guys. Again, if you have questions and you can't join the live stream, feel free to send me a message on Edsby, send me a message via email, and I can take a look at any specific problems you might have along the way. Okay. You guys have yourselves a good day.